Okay, I am Cikgu Nur Muhammad. So on this video, I just want to teach how to draw enthalpy cycle. Okay, how to draw enthalpy cycle from given enthalpy change of combustion. Okay, first we have to write down the chemical equation based on the question. If we read the question, find the enthalpy change of reaction, which is the enthalpy change of reaction. Okay, from the oxidation of ethanol. Okay, so this first step, C2H5OH liquid react with oxygen bracket. Okay, because oxidation and produce ethanol, CHO liquid and H2O. Okay guys, so this is the first step, and the second step, we have to write down the chemical equation for the product of combustion. Okay, what is the product of combustion? Okay, most of organic compound, when undergoes combustion, the products is carbon dioxide and H2O. So write down the product of combustion, CO2 gas plus H2O liquid. Okay guys, so this is the product of combustion, and the third step is, okay, draw the arrow of the reaction. Okay, if the combustion, of course, okay, from the compound produce carbon dioxide, compound from the carbon dioxide, and balance the chemical equations. Okay, so to balance the chemical equation, we can refer either one. Okay, in this case, I want balance, okay, carbon dioxide and H2O, okay, to the left hand side. Or either one, you also can balance with the product. Okay, we have, okay, two carbon, okay, and have a 6 hydrogen, so at 3 here. But if we refer on the rectangle, we have only 2 oxygen, and the products have 7 oxygens. Okay, 7 oxygens. So what we have to do is, we have to add 5 more oxygens to make it number of oxygen is equal from the reactant to the product. So 5/2 oxygen. And for the second for the second equation also have same number of oxygen. Okay, now this is the balanced chemical equation for the enthalpy cycle. Okay guys, so this enthalpy cycle is important, okay, because we can calculate the enthalpy change of reaction from the given enthalpy change. Okay, so the final step, don't forget to add the value of enthalpy change of combustion. Okay, -1371. Okay, remember that this is for 1 mole. Yes, this is for 1 mole. And another one is -1167. Okay, and this is combustion for 1 mole of compound. So yes, of course, this is 1 mole. Okay guys, now we look at the how to draw enthalpy cycle from the given enthalpy change of formation. The first step, okay, write down the chemical equations according to the question. Reaction, oxidation of ethanol to ethanol. So ethanol, C2H5OH liquid react with oxygen, produce ethanol plus H2O liquid. Okay, the second step is, okay, write down the chemical equation for elements. Okay, because this is enthalpy change of formation, and we know that the compound are made up from its constituent elements. List down how many types of element inside this chemical reaction. Okay, I can say that we have carbon, right? We have carbon, we have hydrogen, we have oxygen. Yeah, so write down the chemical equations for the element, okay, based on the standard condition. Carbon at the standard condition exists as solid because it exists as graphite. React with hydrogen gas, okay, at the standard condition, and react with oxygen gas at the standard condition. Now we have to balance the chemical equations. Okay, similar to the enthalpy cycle from the enthalpy change or combustion. Okay, we have to draw the arrow of reaction. Okay, because this is the formations, so the arrow has moved towards compound. Okay, so we have to balance the chemical equations. We have to balance the products. Okay, this equation. Okay, to the ideal one, which is the reactant or the product, because the number of element is similar. Okay, now I want a balance based on the left hand side. Okay, from the left hand side, okay, we have two carbon, so add two carbon here, and we have 6 hydrogen, so 3 hydrogens, and we have 2 oxygens. So okay, already balanced, right? Now our enthalpy cycle equation are already balanced. Okay, the next step is list down the enthalpy change. Okay, from the ethanol, for the formation of ethanol is negative 277, right? Okay, negative 277. And at the ethanol, enthalpy change negative 171.8, right? And H2O, enthalpy change formation of H2O is negative 285.0. Okay, please remember that. Okay, if there are the coefficient number here, okay, the enthalpy change also have to times with the coefficient number, because the enthalpy change of formations are for the formation of 1 mole of compound. Okay, but in this case, we no need to times with the coefficient number, because all the compound have 1 mole. Okay, so this is enthalpy cycle from the enthalpy change of formations. Hope you all understand. Thank you.